Dear students, today we are going to discuss about K-map, that is the method to simplify Boolean expression. I hope that from this video you will get an idea about grouping of terms using K-map.
First of all, let us see an introduction about K-map. What is K? Here, K is the abbreviation of the term kernel. The K-map is a graphical representation of Boolean expression. It contains number of rows and columns based on number of variables used to represent the entire Boolean expression. Each cell of the map corresponds to a row in the truth table. Also, one map cell corresponds to a min tag or max tag in the Boolean expression. It is given to be reduced. Here, multiple cell areas of the map correspond to standard terms or combined to minimize the expression. Based on number of variables, the number of rows and columns varies. Let us see an example for a two variable. Here, we can accommodate 2 power to the 4 terms in this map. So, we need 2 rows and 2 columns. Here, you can place the terms row-wise or column-wise. In the first diagram, that is the first map, we are placing the terms row-wise. That is 0, 1, 2. The second one, we are placing them column-wise. This is 0, 1, 2. So, this is important how we are placing them. That we are taking x1 in row or in column. Here, that is mentioned. Here, x1 is taken 2 rows and x2 is taken 2 columns. Here, cell 0 represents x1 dash and x2 dash. That is, for both the variables, the values are 0. And in cell 1, we are representing x1 dash and x2. That is, for x1, we are taking the value 0. For x2, we are taking value 1. So, like this, we are filling up all the terms or all the cells in the map. Here, an important thing is two adjacent cells in the map differ by only one variable. They appear complemented in one cell and uncomplemented. Here, for example, M0, which assigns 0 for both the variables x1 and x2. This is adjacent to M1, which is similar for the term x1 but not for x2. And in M2, which is another adjacent cell for M0. Here, x1 is different, but x2 holds the same value, that is 0, like M0. But M3 is not an adjacent cell, so it contains both the values different. So like that, we are filling up all the 4 cells in a 2 variable. Let us take an example. So here we are taking a Boolean expression f with 2 variables x1 and x2, which contains 3 terms. This x1 dash, x2 dash, both values are 0. So otherwise it can be called as m0 plus x1 dash x2. Otherwise it can be called as term 1, that is m1 plus x1 x2 dash, that is m2. So ones are placed in the map for the specific terms m0, m1, and 2. So here we are placing them row-wise. That is, x1 values are taken in 2 rows and x2 are taken in 2 columns. And here we are grouping the ones based on the adjacency that map. So by grouping them, we are m0 plus m1. For the second value, there is x2, which has value 0. We are getting m0 plus m2. See here, the top m0 is covered twice in both the terms. Let us see an example for a 3 variable. So here we have to represent 3 variables. Definitely we need 8 cells, that is 2 power 3 cells to represent all the 8 terms, possible terms of the Boolean expression with 3 variables. So we are taking one value, that is x, in 2 rows and 2 values or 2 variables y and z in 4 columns. So we are assigning 2 values 0 and 1 for x and a pair of 0, 0, 0, 1, 1, 1 and 1, 0 for y, z values in 4 columns. Whether it is a 2 variable, 3 variable or 4 variable mapping, here we can combine adjacent terms and with a count of 1, 2, 4 or 8. That is the power of 2 to power 0, 1, power 2 and 2 power 8. Here the possible groupings are given. So you can map each cell individually. That is as a single group where no adjacent variable is not found. Otherwise, you can combine them as a group of 2 adjacent cells. So these are the possible ways. So you can combine these 2 also for the same, and if this one is different. Like that, you can combine them 4. So you can combine all the 4 terms in a row. Otherwise, 2 terms in the first column and 2 terms in the last column. Otherwise, you can combine 2 adjacent columns like this. So you can combine these also if all the 4 are found. So these are the possible ways to group the adjacent terms. So here we summarize the steps to simplify Boolean expressions in K-map. So first of all, we have to plot the K-map with the given terms in a Boolean expression and circle all prime implicants on that K-map. Then identify and select all essential prime implicants for that cover. That is the adjacent terms which have common Boolean value. Then select a minimum subset of the remaining prime implicants to complete the cover. That is, you select without any repetition. So you select the terms as much as possible. Then read the K-map. So here one example is given. So we are using 3 variable K-map or 3 variable Boolean expression with the variables A, B and C. So we have to fill the terms 1, 2, 3, 5 and 6 with Boolean value 1. So next step is to circle the prime implicants. Here we have identified 4 prime implicants. This is a possible adjacent cells. Then you have to identify the essential prime implicant. That is, you have to eliminate the redundancy of the combined prime implicants. So here for this one, you don't have any other adjacency. So you cannot omit this combination. Like that for this one also, there is no other adjacent cell with the value 1. So you take these 2 as a prime, so essential prime implicant. So like that, this also. So this also another essential prime implicant. So you can take these 3 combinations and you leave this one as prime implicant. So we are taking the terms, the common terms for both the values or both the terms in the essential prime implicant. So you will get A bar, B, C bar and B bar C. So this is the simplified form of the given Boolean expression.
Thank you for